In calculus now we're going to move on to something called parametric equations. Some of you may have seen this in pre-calculus, but if you haven't, then I'm going to start from fresh, so don't worry about it if you haven't heard of them before. A parametric equation is set to be two different equations, usually x equals and y equals, and they're in terms of t. So let me just give you an example before we move on and I explain the rest of this. It could look something like x equals 3t, y equals t squared plus 1. So that would be an example of a parametric equation. Now it's a pair of equations, but it's considered one whole equation put together. So first of all, one thing you may see in some of your textbooks is that the word rectangular, like they might say convert from parametric to rectangular. Rectangular is just the normal type of equation you've been working with since you were in middle school, or probably before that. So rectangular is just the regular or the normal type of equation you're used to seeing. Y equals 6x squared plus 4x, or something like that. Y is a function of x. That's the normal rectangular form. Now, parametric equations are really good in allowing us to see how x and y change individually with respect to time. One thing you may want to know sometimes when things are moving is how they're moving horizontally and how they are moving vertically. Especially if you've taken physics, you know that forces happen in different directions. So it's helpful sometimes to be able to separate the fact that you are moving horizontally a certain way and vertically a certain way. So first thing is just knowing how to plot these. So first I've got it written out here, and then I'll show you how to do it in the calculator. Our formula is x equals t squared minus 4 and y equals t over 2, and then they do have to give us an interval for the time, negative 2 to 3. So what I did is I just picked, and actually I have one extra here, so let me erase that, is I took the numbers negative 2 to 3 and I plugged them in for x and y. So first thing I did is I took negative 2 and plugged it in for t squared minus 4, and then plugged in negative 1 to t squared minus 4, and then 0, and so on. And that gave me all of my answers in this column right here. So I got those numbers by plugging the t values into my x equals equation. Now then I had to find my y values, so I took all the t values, plugged them into this equation, and that gave me these. So if you want to double check those, feel free to pause here and just make sure you understand where those numbers came from. Now it looks like you have a triple pair instead of an ordered pair, or I guess it would be an ordered triple. There we go. But as far as graphing, you'd still graph it normally. You just use x and y. So that would be your ordered pair, and that would be your ordered pair, and that would be your ordered pair. And if you look over to the right at my graph, that's exactly what I graphed. 0, negative 1, negative 3, negative 1/2, negative 4, 0, negative 3, 1/2, and so on. And you notice I drew arrows to indicate which direction I was traveling, and that's a good habit to do so you know where you started and where you're going to stop. Now you can also do this in the calculator. So if you pull up your calculator, first thing you need to do is change the mode. You may not have had any idea your calculator had other modes when it involved this, but it does. So if you go to mode, right now you're on function mode. But if you look to the right, there's one that says PAR, and that's short for parametric. So if you hit enter, it changes it to parametric mode. And if you go to y equals, it suddenly looks very, very different. So let's clear out what I have here. Sorry about that. And let's plug in the one we had, t squared minus 4. If you notice, the button you normally push for x now automatically gives you a t. That's because you're in parametric mode. And then we need to plug in for y, t over 2. And you have to plug in something for both of these for this to work. So let's go to our window, because that's where we can change the fact that we want the t minimum to be negative 2 and our t max to be 3. So let's graph this. Sorry, I need to change my zoom. Give me just a second. Negative 2 to 3. Here we go. Alright, so that should look a good bit to you like what we graphed here. Same shape. So that's how you do it in your calculator. Okay, one thing they may ask you to do is convert from parametric to rectangular. Remember, rectangular is just the normal form. One thing they might say is eliminate the parameter. T is your parameter. We're trying to eliminate it. So since we normally have y equals something with x, what we're going to do is take the x equation right here and solve it for t. So I'm going to add 4 to both sides and then take the square root of both sides. So square root of x plus 4 equals t. Now we take t, that is the square root of x plus 4, and plug it in for t. So we get y equals the square root of x plus 4 over 2. And that's our equation. So this is equivalent to, let me put it this way, this is equivalent to this. That is, one is the rectangular form, that's the normal regular form, and one is the parametric form. Now sometimes they're going to throw one at you like this, where it's sine and cosine. Well, some people, when they get to this, want to use inverse trig to make this work. I honestly don't know if that's allowed or not. I just know that I've never seen it done that way. Whenever they have sine and cosine, they want you to use the identity sine squared plus cosine squared equals 1. Now if you notice, this is just theta, and these have 2 t's. Well, that's okay. As long as what's inside is the same, you can still do this. This identity holds as long as these two are the same. Because if you think about it, we're just saying, oh, okay, well, theta is equal to 2t. So as long as the insides are the same, this works. So we need to solve for sine and solve for cosine. So here, we're going to divide both sides by 3, get x over 3 equals cosine of 2t. Here, we're going to divide by 4, so we get y over 4 equals sine of 2t. So then we just plug those in. So sine is y over 4, so we get y over 4 squared. Cosine is x over 3, so we get x over 3 squared equals 1. Now these aren't functions in the traditional sense. If you notice, I'm mostly using the word equations. These will fail the vertical line test, but that's okay. We're just converting between equations. Alright, we're going to go ahead and stop right there and look at the calculus involved with parametric equations in the next video.